Well, it's lovely to be here, and I know it's late August, or getting to late August. So for those viewing on YouTube as well afterwards, this should be a talk that gets you thinking a little bit outside of the box in terms of standard data science and artificial intelligence conversations, but I think it's one that is really important that people have, and that the uh, tooling and the thinking around artificial intelligence governance is something that we need to be working on as we go into the future, as more and more companies are adopting artificial intelligence into their ordinary operations. And this is a conversation that has come out of my own history working with artificial intelligence, both in the academic environment, but also with company that I've done in the past, working with natural language processing, specifically for cyberbullying detection. And other companies in the area have, I think, done a lot of work to begin the process of um, quality control in areas of deep human impact. And the ideas that I'm going to be presenting are not in a bubble. I've been working with my team at Fairly on developing a product for AI governance, and a lot of the ideas come from people in our day-to-day operations. So I want to give credit where credit's due, and this includes product development that's been worked on with my co-founder Fion, Pablo, and Sindhu especially, and our developers William, Jonathan, and Leroy. So I just want to thank them for all of the contributions that have gone into this. This talk is going to cover governance in general as we begin, and this deals with the fundamentals of institutions and the notion of fairness that comes out of political philosophy, and that then applies to artificial intelligence and its applications, both within data model itself and machine learning models, as well as their use within larger organizations. And the idea of taking a policy in a more traditional sense, as used in organization, and applying it to artificial intelligence is something that we're working on in my own product team, and something that is being developed in the academic literature, especially in the last couple of years. And I'm going to talk a bit about fairness through unawareness, which is the de facto method of debiasing by removing sensitive information, and then more sophisticated ways of doing this, including through adversarial debiasing and other techniques and measures of fairness that can be applied within optimization metrics and within decision procedures for whether or not to release artificial intelligence models into production. And I'm gonna finish with some thoughts, some of them a little bit more at the level of product, and a little of them at the level of future directions for research into governance systems for artificial intelligence, along the idea of a policy applied to artificial intelligence. So before we start, I just think we need to step back a little from ordinary artificial intelligence and data science thinking at the model level, and consider the use of artificial intelligence systems for human impact areas. So while machine learning model might be trained on a test set that has a very limited scope of application, if you have the model run in production in areas like insurance, human resources, and areas like criminal justice, where you make say a prediction of whether or not a person is likely to commit a crime. We have to think in much broader social terms than ordinarily we might be thinking. And this is where we're starting. So to give an example, it's become a pretty standard data set in the AI fairness literature around this product called Compass. Compass was a company that put out a model that was used in some court rulings, and these rulings were given to judges who would look at a case, and because they had a very short time frame for making decisions, very often the predictions from this Compass software were used to influence a judge's decision about whether or not to offer probation. And in the extreme case, a judge would just rely on this. And so if you have a case where a judge is presented with this graphic in front of us, and they see that one person's a low risk for reoffending and the other is a high risk, the judge will very likely give probation, say, to Vernon and not give probation to Brisha in this case. So the history in this particular case was that Brisha was apprehended for theft of a bicycle, and Vernon had a long history of violent offenses. But given the systemic discrimination in the criminal justice system, people who are Caucasian and previously being reviewed by judges were let off, whereas people of minority status, Black, BIPOC, were given harsh sentences. Given this historical data, when you take a machine learning model and you make a prediction of whether or not a person is likely to be apprehended or whether this person's likely to commit a crime where they're given a long sentence, the risk goes very high towards the person of a minority status within the model, simply because of the historical data that was used to train these models. And when artificial intelligence was first used in the judicial system, there was not a lot of understanding of how it behaved or the quality requirements around testing. And so you take a training data set that consists of biased historical court decisions and historical biased policing, and then train a model on that, and then test it on a held out test data set from that model. And the result is that you appear to have a very accurate model in which racial discrimination is reinforced, and it does not agree with the actual ground situation of what's appropriate in any given case. So this is a motivating example. And to provide artificial intelligence systems as tools of the state is a much bigger problem than simply whether or not you're able to get an artificial intelligence system to perform accurately within a prescribed test set. So I wanted to step back a little and look at the notion of fairness that comes out of the philosophical literature. And John Rawls is a major thinker of the 20th century, and especially with the notion of redistributive justice and the grounds of legitimate governments who are able to then make judgments about particular cases that affect people's lives. And so his idea is that if you look at a data set that consists of natural facts obtained within the world in a database that you then go and train a model, you're looking at a natural distribution of goods. If you're looking at, say, an insurance history, whether people were given a loan or not, this is just the facts of the matter within an organization. It's a natural distribution. And Rawls's positioning here is that there is no question of fairness. These are just brute facts. But once you bring in an institution to settle disputes or to provide decisions that affect people's lives on the basis of this, you then are dealing with matters of justice and fairness. And so the way that you handle decisions becomes important. He legitimizes the state by going through a thought experiment. And in this thought experiment, we are given kind of hypothetical place of reasoning by people that might want to form a government, in which they start from a position of ignorance, a very specific kind. So they know what humans are like, they know what society is like in general, and they have common sense, but they don't know what country they live in, they don't know what time it is, they don't know who they are, and they don't know what the things that are motivating people in particular are in that society. And this is a way of determining fairness by removing your own personal interests in a very serious way of removing them completely from your decision-making process about what kind of government you want and what kind of decisions you want to make within it. And so you do not know what race, ethnicity, gender, so these are protected categories, you have personally or the citizens around you. And by putting yourself in this position, you have to think about what would be best for you if you happen to be any other person within society. It's like putting yourself in someone else's shoes. And so he reasons that people will adapt a certain form of reasoning about how to distribute goods. And this is to follow Maximin Reasoning, or to maximize the minimum level of primary goods that a citizen might find themselves with. So if you remove yourself from this place of ignorance and become someone, anyone within society, you want to make sure that you're in the best position that you could possibly be. And so this would be to select a state and a set of distributive, a scheme of distribution of goods, so that you're the most likely to be in a position that's at least tolerable. So if you're the worst off, if you end up in the worst off position, you want that to be as good as it can be. And then he goes through a series of stages that get us back to the actual state where we're in. And this is, again, kind of hypothetical reasoning, where you begin with the original position, or where you don't know who you are and what exact society and political system you might end up being in, and then settle on a couple principles. And he thinks, following Maximin Reasoning, you're going to say, definitely everyone gets a basic set of freedoms, and everyone needs to have these, no matter who I am. We need to have these. And then he has thing called the difference principle. So he says maybe it would be great if we all had the same goods and that we are all treated exactly equally. But there might be a better way of doing things. There might be a better world, one in which even those who are worst off are still better off than they would be if everyone had exactly the same set of goods. And so this is the difference principle, where you're given, everyone has equal opportunity to make the most that they can of their life. And this will be motivating to people, that they're going to be able to achieve things that they might not achieve if everyone was just given the exact same set of goods. And then the second one is that the least advantaged, no matter what, still have to be benefited. So if there is inequality, it can't mean that some people have a really bad life as a result of it. It has to be that everyone's life is elevated, and some might be elevated even more than others. But at least those who are in the worst position are better off than if everyone had the same set of goods. So after deciding on this, he thinks people will agree we now need to have a constitution. So he removes a bit of the veil of ignorance, and with this removal, we get to a place where we know general facts about society and what people are like within that society, and then form a constitution. And it's a constitution that's meant to guarantee the things that have been decided on for those basic principles. So the basic liberties, and a constitution under which a group of people are able to start from a place of equal opportunity and achieve as much as they possibly can, and not at the great expense of others, where others would be worse off than if you had just given everyone equal amounts. So with this constitution, then we get to the third stage, where we get very detailed facts about our society and write very specific legislation that's based on the principles in the constitution. And then from there, we are fully aware of who each and every person is, and we select judges and administrators, and then they administrate based upon this constitution. So this is a very foundational notion of fairness that's been used in politics, government, and thinkers throughout. And I want to quickly jump to a contrasting view, Robert Nozick, who has a different foundation for the states, and then the notion of fairness that comes out of it. And on his view, we have a very similar beginning, where we are thinking from a place where there isn't a government. And for him, we start by thinking about the natural rights that we have. And these are rights that people have in order not to be interfered with, primarily. That people can't come around and kill you, for example. People can't come around and take things from you. And then we move in our thinking from there. So we begin with our set of rights, and we have claims to things. So using the philosophy of John Locke, he thinks of us as owning ourselves and owning the fruits of our labor, and then having these kinds of rights as fundamental. And then those who violate our rights, we have liability created in order to remedy the situation. So then the state that comes out of that is very minimal. And it's one in which, while people are going to maybe pay others to help protect their rights, and they're legitimate in doing this, they have the right to protect their own rights and enforce them. And then when they pay other people, there will be a society, a protective society that emerges in order to have a few people that are really good at that, do the policing. And then there'll have to be a dominant one, because they'll start fighting against each other. And that then becomes the minimal state, which enforces our rights. And this, he thinks, is something that we're not going to have what he calls patterned theory, a pattern scheme of distribution, like what John Rawls has, where you have to take away from some people in order to give to others, in order to guarantee that they have the minimal guaranteed amounts of rights. And he has an argument that's quite famous with Wilt Chamberlain, is a basketball player from the time, where he says, let's say that we did agree on a scheme like John Rawls's, where everyone is given equal opportunity and a basic set of goods, and we only allow people to do better than others if that advantages everyone. He calls this a pattern scheme of distribution. So if we're in a place where we have a pattern scheme of distribution, there may not be a chance for some people to become very rich, for example. So he says we start, let's say we're starting there where everyone has a pattern scheme, and then this basketball player is very famous at the time. He charges 25 cents for people to watch him play basketball. But because he's so famous, he's able to do this from hundreds of thousands of people and become very rich. In this case, the enforced pattern of fairness or equality is going to result in either a prohibition on people giving this basketball player the 25 cents. They can only pay him, say, 3 cents, because otherwise he'll become too rich. Or else we'll have to take the money away from him and give it back to the other people. And this he sees as a fundamental violation of a person's liberty. So I go into all of this in order to say that before we start talking about machine learning and about fairness in machine learning, the notion of fairness is complex. It comes from a deep system of thought. And by correcting fairness and bias in machine learning, we can either try to prop up a scheme where everyone has equal opportunity, or we can try to prop up a scheme where you shouldn't interfere with the accurate prediction of a good or bad outcome for those people who are affected by your machine learning, because that would amount to doing something like taking the goods from the people that end up coming out on top and giving them to those who don't come out on top within a decision function that approximates the natural distribution, which is their right. So at this point, I'm going to stop and we can do our breakout session. The question we have here is, how can we define algorithmic fairness? So based on what I've just spoken about in terms of redistribution policies and how a government can be fair, how do we possibly define this in terms of algorithmic fairness? And how does that differ from our regular understanding of fairness? Okay, so next section is on governance for machine learning, governance systems. And this is what we're building out at Fairly. And it's something that is going to be a long process. And when built out, it is a matter of governance within specific areas of application, as well as specific technologies that are being used. So some things that come to mind when people think about what needs to be governed within artificial intelligence systems is things like loan approval, credit ratings, where these systems are drawing on historical data and information that might be very personal and might not be interpreted appropriately, and also might be biased against some people. Border crossing systems already use artificial intelligence very heavily. If you apply to become a citizen of Canada, your application gets reviewed by an artificial intelligence system. And based on some conversations I've had with people in government, I believe that you actually can be approved as a citizen without a human looking at your application until a very late stage of it. And that means that those who are not approved are being potentially discriminated against because there are eyeballs looking at their application and not other people's applications. Access to healthcare, especially as we digitize healthcare, more and more of our healthcare system is mediated by things like maybe in the future chatbots, but also whether or not you're triaged in a digital healthcare system and how your data is used is subject to a lot of fairness issues and the AI systems built around it as well. I know that healthcare is trying to minimize costs as a very high priority, and the cost of treatment can be used in machine learning models as a target variable. And if this doesn't treat people fairly, then we are developing a system using artificial intelligence that is not legitimate in a Rawlsian sense anyways. Data scientists have specific knowledge of technology, but maybe not of the social, cultural, political sides of making these decisions. And machine learning that's released through institutions then needs to be regulated, needs to be monitored, and it needs to be held to account. And the people that are meant to do this are typically not technical and don't understand what's going on. And that is a fundamental problem. So if we step back from machine learning and think about policies, here is a list in Ontario of employment policies that are legally binding that a company must have and agree to. And then there's a huge number of other policies that you can be pulled into court around if you fail to use and implement properly. So you can scan the list. Accessibility as well as pay equity are legal requirements here, and they can then be impacted by resume screening. But also you can be sued for discriminatory practices during hiring. And there is a large concern within organizations around this. And so if you've applied for a job, you can see that your information like age, gender, race is gathered but not used within the hiring decision. At least that's how we're messaged. And that is in many ways because of a desire to get things right, and also to avoid the liabilities associated with being perceived to or being found to discriminate. And the payouts can be sizable. And this is not just theoretical. Amazon used HR system that would prefer men over women because they had an AI component to the filtration of resumes, and would bubble the men up to the top and not the women so much. And when it was understood that this was the case, Amazon had to pull it, and they got some bad media attention at the very least. It was a sign of things to come as well. And what happened in that case, interestingly, was when you have the string women in a resume, even though you've removed information about the gender from the algorithm, it's not explicitly told that this is a man or a woman. But if you have the string WOMEN, like it showed up in a description of your women's basketball league, for example, the algorithm would learn very quickly that this was a high valued feature input, and that if you are a woman or if you use that word, then based on historical data, you are less likely to be given a job offer. And so it learned this and it perpetuated it. And so this gives a very good understanding of why it's not enough for artificial intelligence systems to simply remove the information that's explicitly fed to it that might lead to it discriminating. And so we're thinking in this case about specifically protected categories: race, age, gender, veteran status, disability, and LGBTQ, and other ones that are legally protected. And this is a danger that's currently taking place, where it's like covering your eyes in order to shield yourself from legal liability, even though an algorithm is very capable of picking up data that is identifiable as a biasing in one way or another. Resume screening is also interesting because HR often has hiring policies to have a minimum of, say, 20–30% BIPOC employees. And if you're scanning out people of color, you're less likely to hit those targets. And so there is a interest even from within the HR departments of having tools that do favor some people over others while also not wanting to. So it's a very interesting position to be in, why it makes for an interesting use case. So there is a lot of research that's come out in the last few years, especially on fairness within algorithmic decision making, and the idea of fairness through unawareness that we just talked about. So getting rid of explicit protected category information is something that's been debunked, and the reason is redundant encoding. So if you see the word woman, then you're likely to think it's a woman and just prefer them in your algorithm. So other notions of fairness that can even allow for the inclusion of protected category information have emerged. And this is where you will use techniques like adversarial debiasing to train an algorithm so that it satisfies one of these conditions. So the first one that was used, it got some play in the literature and is in some senses intuitive, is one in which you have demographic parity. And this is where given that someone is a man, the odds of success should be the same than they would if they were a woman. The problem with this is that you end up having a forced situation, kind of like what we talked about with Nozick, where you're enforcing a scheme of distribution on people that might not be accurate or natural. And in this case, if you're just doing it in a brute force way, you might actually take people who should get jobs and not give them those jobs in order to just make things equal. We don't need exactly equal numbers of each person or each protected category, representatives of each protected category. If it so happens that some people are more suitable than others on the basis of their raw talents. What you want is to avoid actual discrimination. And so if we look at equalized odds, we have a better option here. So basically it prohibits abusing a protected category status feature as a proxy for the target label. So what that means is that you can't have an algorithm that satisfies equalized odds is one where it's not better able to make the prediction because it knows that you are a woman or because it knows that you're a man, to be on the gender case. There's now very interesting paper, and I think a few more that have come out actually specifically about Rawlsian's idea of Maximin fairness. And here it takes people that belong to protected category status, and you can segment them to however many you have represented in your data set. And this technique effectively uses the notion of Rawlsian Maximin fairness to say that an algorithm should aim to optimize the outcome for those within the protected category class that performs the worst on that algorithm, and to prefer an operation in which the worst off, the protected class that has the worst outcome ends up having a better one, if that's possible. So we maximize the utility of the worst off group. And then this can be used in co-training with more standard estimator that is just trying to achieve the correct outcome. And by working the two together adversarially, you're able to get a more fair outcome. There's probably 100 or more conceptions of fairness within the machine learning literature that have had some discussion, and they get grouped together in various libraries, like IBM's AIF360, for example, has a great number of measures of fairness. And none of them are very well understood by people who are in a position to make decisions. And there's interesting work that's come out quite recently where they actually went and did surveys and comprehension tests of various algorithms. And they found that those who have a higher education are more likely to understand how a measure of fairness would be used, and those who do not understand the algorithm have a very negative sentiment towards it. So this gets us to a bit of a design problem. If you have a decision that needs to be made about whether or not to use a particular artificial intelligence algorithm, whether you need to extend the budget on a project where you're developing these algorithms in order to make them more fair. These decisions are very often made at the managerial level, where there's less understanding of what's involved in actually making algorithms fair. So the engineering team might choose variational autoencoders, or try to apply game theory, or use adversarial debiasing, and the people who are tasked with enforcing organizations' policies at the operating committee level, for example, are not aware of how these technologies work, and they are focused more on the Human Rights Code or the Federal Trade Commission guidelines. And there's a very large disconnect between these two kinds of people. And the issue is that decisions are made at a high level and at engineering level, and there's not a lot of communication between the two. So given this, our discussion topic is who should be behind the decision of what fairness definitions an organization uses. And in the case where it really should be at the regulatory level, at the operating committee level, how can engineers help them to make their decisions better? I'm giving some analogies to other systems that manage a lot of complexity and have human users at the end. And so we can take the extreme of the single magic button, like the nuke button that some people think is on the president's desk or nearby. But the concept of a single button that can set off a complicated chain of reactions is the kind of extreme user case. And I think a lot of people would love to have a fairness button if they could, just make it fair. And the experts will figure out how to actually make that happen. So that would be the extreme kind of user interface where we say delegate it all to the data scientists, to the software developers, and maybe those domain experts in the area, and they will take care of all of the issues. And the decision-making process of those who are at the top of an organization around their use of artificial intelligence is then simply to delegate it. And so it's not completely out of the ordinary for this to happen, and that's one way that we could have an interface for non-specialists. I think the idea of cruise control within a car, and then also for messaging, say the check engine light, is something that might be a little bit more in the realm of possibility for a kind of responsible use of artificial intelligence, where there are some options that are presented to the non-specialists that are meaningful. And when they make a decision, there is a process, maybe semi-automated, maybe mostly automated in a mature industry, where they can say, pick a particular conception of fairness, and that's the one that I want implemented in my artificial intelligence. And then a third one that Sindhu on my team has really brought to my attention as something I think is quite workable and sensible is an analogy to something like the environmental management systems, which, I mean, it's not the best analogy because people don't tend to know what they are, how they work, but when I explain it, I think it'll make some sense. If you are doing impact analysis on a water system as part of an environmental management system, then you have specialists who go out and they provide information by measuring soil samples for some particular measures. And the people that are responsible for protecting the environment within an organization at the executive level are certainly not going to know what any of those measures mean. But nonetheless, there's a reporting system that's software based and tracks all of these measurements, and then a manager at some point who actually has an environmental studies degree or some kind of sophistication in the area is able to go into a software system, look at the results of those measures, and say whether or not they think that a particular watershed is compliant with their policies. And then this then also gets reported to regulators, and they're able to understand. I think artificial intelligence is going to end up more like the third option, and the first two are ones that we might play with. The second one could be something like this, though. If we present to a person who is responsible for overseeing diversity within a company, and they look at the hiring system, they might be able to say, okay, make the AI agree with, say, individual fairness, where differential treatment between any two individuals that belong to different protected categories, like race, age, gender, should be, they should have kind of equal outcomes. Or you could say, I want my AI system to provide the positive, desirable outcome to people of every ethnicity equally, so that on average, whenever it sees a Black woman or a white man, on average, it's going to give the favorable outcome the same on average. Or they could say, I understand what it is to prop up the worst off groups amongst us, and I want to have my artificial intelligence systems do a kind of redistributive justice kind of approach, where we are going to make sure that those groups that are historically worst off are then given the best possible outcome, but allowing for the fact that different groups are going to have, on average, different outcomes. So not group fairness. So one more like Rawlsian. This can be presented to non-experts, they can understand it, and then the measures that we've looked at previously can then be written into the code and used for training and testing models. On the third option, that's more like the environmental management system. What we would have is a business user who's non-expert signs in, they oversee a number of different divisions within an organization. They go for HR, they say, let's look at hiring policies, and then they're presented with some information like, here are the risks in your hiring that uses artificial intelligence systems within an organization. And then they say, okay, let's look at resume screening, and then they get a risk assessment for resume screening. So they're non-experts, but they're given the information that they need through a guided procedure. Then they would say, okay, let's look at gender, and let's look at gender bias can come up. Oh, I didn't know that. And then they will say, you have to worry about the inputs to your algorithms. You have to worry about what training data sets you're using. And you have to worry about whether there's some feature engineering around gaps in employment, whether you're favoring some educational institutions where men are more likely to get in, or whether you've given job descriptions that are favoring men over women, and this is now biasing your decision. And then it gives them a menu of options, and these options then they could say, I'll defer to the experts, or they'll write an email saying, this is where it gets kind of probably more like it should be provided to the data scientists themselves. Why don't you try adversarial debiasing? Why don't you try recalibrating your weights? Why don't you get more representation of women in your data set? And on account of information management system that is presented with information about training data, testing data, and the model test results, it would be very much similar to an environmental management system that receives information about toxins in soil and then presents this to people who are able to make decisions. And this is consistent with a number of papers that have come out in 2019 that talked about information that needs to be provided alongside data sets and machine learning models and AI services. So there's 3 different really influential papers that have suggested that things like a data provenance needs to be always provided with a data set that's used by any data scientist that will tell them where the data came from, what information it contains that could be a potential problem, and what they can do about it. This would be similar to what's very common in the electronics industry, where you don't get an electronic part that you're going to use in your cell phone, for example, that does, anytime that you get a part that you're going to put into your cell phone, you get documentation along with it that says how it performs, where it came from, all the sourcing and so on. So this needs to also be applied with data sets. And then that was extended to the idea of trained models. They need to come with tests and the results on those tests. And then the AI services was clearly something that needed to also be documented well. And so they, in these papers, provide very long appendices with a lot of information, but some information is more interesting than others. So the people who make decisions need to be presented with the most relevant information. So if you look at Faces in the Wild data set, it only has 22% female subjects, for example. That's something that needs to be bubbled up to the top to the decision makers who say, okay, well, we got a problem with their data sets because clearly they're not going to perform as well for women as for men. Or something that's a little more segmented, was reported that Black lesbian women versus white straight women had very different performance in terms of AUC in the Perspective API's toxicity detector. And so knowing that these differences in performance are going to affect people who are impacted by a company that, say, uses the toxicity detector for content moderation. This is something that needs to be known by those who are making use of it, and it is quite possible to run automated tests that provide this information and then select the most useful information to those who need to make the decisions. And I won't get into depth on how the most relevant information could be automatically presented to these decision makers, but just to give a kind of sense of how this could be done, if you think of governance of artificial intelligence within an organization, from the training data to the testing data to the out of domain data to the managers who are making decisions to the production use of it to how it feeds into other parts of technology, you have a very complex system, and it's kind of like a room that a Roomba is going to move around and figure out where the entryway is, where the hallway is. It has to learn its environment, and then it needs to make a decision about what the next best move would be. Go left, go right, go up, whatever it is. And the technology to do this that makes the most sense to me, as at least something to explore, which is something we are doing, is to use reinforcement learning techniques, and to do this to try to simulate what a really intelligent agent of the government in regulations should be doing in order to determine what is the biggest risk within machine learning model lifecycle and deployment, and then to bubble that up to the top in order to have remediation. So this is not my own idea. This comes out of Dan et al. And there's a few other papers in the area. So if you take a reinforcement learning system, it has a policy, which is just what is the next best action that agent should take within an environment. And because the performance changes drastically based upon where it is within the environment and where it is within its own system of learning, it needs to say how confident it is that the next move is the right move. And then they suggest that you have, they call this a certificate. And then if the sum of the rewards over the next episode are below a certain bound, then that means that it's not confident about what the next thing to do should be, and that can then have a human intervention at that point. The environment in which a Roomba effectively, or a reinforcement learning system that's focused on governance would need to interact with would be the training testing data and the metadata around it, the model test results on a number of different data sets, the deployment environment, and then the decisions and activities of the human practitioners and managers. And then the each of those break down into further systems that can be developed within an organization, data scanning techniques. So for ourselves, we train baseline models on data sets as part of our scanning, and then we do a number of performance metrics on the results of those baseline models, and so that we know that a certain data set is likely to be biased on that basis. And then actually doing model test results and having a reinforcement learning system that's aware of the entire organization can then feed back information to raise or lower the thresholds of tolerance for what's appropriate or not based upon the other impacts. And then manual and tests. So impact analysis that's done manually by domain experts, but also by using additional data sets that have not been used as part of the model development process is another way of bringing more insight into the performance. And then of course, human input. And this brings me to the end of my chat, and we have a final discussion topic, which is, so if we were to try to build a kind of reinforcement learning system that I sketched, or simply more generally speaking, if we're trying to figure out what, so a reinforcement learning system is going to need a kind of reward system, and it could be making more money as a economic incentive. It could be any number of other things. The more general discussion would be simply, why should organizations care? What is the economic incentive? Because that's primarily what a business is motivated by, is to increase the profits for their shareholders. So why should they care about any of this? And if not, is that a problem? I'll leave that at this.